find probabilities for the standard and non-standard normal distribution. In question A, we want to find the probability that z is greater than 1.36. This is really just giving us practice with the normal CDF function, because when we want to find normal distribution probabilities, normal CDF is the function that does that for us. In this situation, we want to find the area underneath the normal distribution curve, starting from 1.36 and as far right as we can possibly go. The normal CDF function accepts two inputs. We have a lower z-score and an upper z-score that we provide as inputs. Our lower z-score is going to be the value 1.36, and the upper z-score is going to be positive 10. And remember, we're just representing positive infinity using the 10. In terms of z-scores, positive 10 is large enough to represent positive infinity. So when I come over to my calculator, second distribution, normal CDF, 1.36, comma 10. It calculates my probability for me. So I have 0.0869. Part B, the probability that z is less than 1.17. If I draw a distribution and shade it, let me make this a little bit smaller, then all I need to do is approximate where 1.17 is on my normal distribution curve and shade to the left. So I have my blue area to the left of that value. Now I'm going to use normal CDF again to calculate the area underneath the curve. And the two inputs that I need to provide are the lower z-score and the upper z-score. In this case, my lower z-score is going to be negative 10, so I'm going from negative infinity up to the upper z-score, which is the 1.17. So second distribution, normal CDF, negative 10, comma 1.17, and I get my answer of 0.8790 when I round to 4 decimal places. Part C, the probability that z is between negative 0.73 and 1.41. So again, if I draw a distribution, then what I need to do is approximate where 1.41 is and negative 0.73. I'm shading the area in between here because I want z to be greater than negative 0.73 and less than 1.41. When it comes to using the calculator, it's actually a simple situation because you're always doing a between probability as far as the calculator is concerned. So we just need to put negative 0.73 and 1.41 as inputs to the calculator. So let me get the normal CDF function, negative 0.73 and 1.41. And my probability, rounded to 4 decimals, 0.6880. Lastly, in part D, find the probability that x is between 80 and 92 when mu is equal to 75 and the standard deviation is equal to 10. The only difference here is that we are not working with a standard normal distribution. We're using a non-standard normal distribution. In all of my standard normal distributions, the axis is labeled with z-scores, The mean is 0 and the standard deviation is 1. The only difference here is my mean is 75, so 75 is going to be in the center. My standard deviation is 10, so I'm going to have this first value is 85, then 95, and 105. And going the other direction, 65, 55, and 45. So let me draw that and show you what I mean. Okay, here we are. Whoops. Let me make this a little bit smaller so I can fit it on screen. And it would be good if there we are. Okay, so the distribution I have centered at 75, and I marked off in terms of multiples of 10 along the bottom axis. That's because we need to make this still a little bit smaller. That's because the standard deviation is 10 and the mean is 75. So that's why I did it that way. And I've approximated where 80 should be on this scale. And I have approximated where 92 should be on this scale. So now what I'm going to do is type into my calculator normal CDF as well, just as we were doing. The first value is 80, the second value is 92, but I have to provide it the last two inputs of the mean and the standard deviation. Otherwise, it's going to interpret these two values as z-scores, and a z-score of 80 is next to nothing as far as we're concerned, and 92 is 92 standard deviations from the mean. That's really far. So in order to interpret these as x values instead of z-scores, we have to provide these last two inputs. So normal CDF, 80, 92, 75, and 10. Now I come up with my probability, 0.2640 when I round to 4 decimal places.